Hello my dear students, hope you all are fine, and in the last two chapters we have studied about the motion of objects only, considering the motion only, not the cause. If you are studying about the motion only, then that is called the kinematics, as we have seen in the last classes, and if you are considering the cause for the motion, then that is called mechanics. From this chapter, that is the laws of motion chapters, we will be studying the mechanics in class 11th standard. Before getting into the topic lesson, let us see what are the topics which were deleted for this academic year 2021. Deleted topics for this year is concept of force, inertia, Newton's first law of motion, momentum, Newton's second law of motion, impulse, Newton's third law of motion. These are the topics which were deleted and we will not be discussing here, and straightly we will be go to the topic friction. What is friction actually? When a body is tending to move on another body or moving on the other body, a force come into play when the contact in the contact place, that is when we are having like this. Let us take an example like this. This is the body placed, a box placed on a book. I am applying force, a minimum force, but the body is not moving, and if I am applying the sufficient force, then the body starts moving. So, a frictional force which comes into play between the contact places, that is called the frictional force, or simply we can say it is a contact force. It is a contact force. It is a contact force which is opposite to the relative motion, opposite to the relative motion. That means if a body is moving, on another body, the second body will not allow the first body to move upon, and similarly the second body will not allow the first body will not allow the body to go back. So, there is a relative motion, which is being opposed. The force which is in between in the contact, that is called the frictional force. Okay. What will be the direction? Direction is always opposite to the contact force. It is always opposite to the contact force. So, this is about the friction. Frictional force is a force which come into play when a body tending to move or move on another body, force which is in between the contact, that is called the friction force. Then what is the cause of friction? What is the cause? This is due to the irregularity in the surface of contact. That means the irregularity which is existing in the contact surface is leading to the friction. Let us take like this. This is one surface and this is another surface. So, there is a irregularity. If you see the surface is very smooth, that is not actually smooth. If you see the surface microscopically, then you will find that lot of irregularities are there. Due to that irregularity, the body is not able to move, a frictional force is come into play. If we apply a force in this direction, here we will be having a counter force, that is the frictional force comes into play. Now, let us see the types of friction. Three types of frictional forces are here. One is static friction, limiting friction, another one is kinetic friction. Now let us focus on static friction. As the name itself suggests that static means rest. When the body is at rest, when a small amount of force is applied, then the body is not at all moving. It has the tendency to move. It has the tendency to move. That is, a small amount of force is applied, it has got the tendency to move, but it is not at all moving. So, it is in rest. That is, the frictional force which comes into play when a force, external force is applied, then that force is called static friction or frictional force. Okay. If we are taking again the same example here, a box is here and I am applying a very small force. Though I am applying the small force, the body is not moving. So, very small force is applied, the body is not moving, but where the applied force has gone, that is countered by the, that is being countered by the frictional force. That is being countered by the frictional force. I have applied force along this direction, but the body is not moving, that is being compensated by the frictional force in opposite direction. That is why the body is not moving. Such friction is called static friction, at which the body is at rest. Okay. Now come to the limiting friction. Up to what extent the body will resist the applied force? Some extent is there. If you apply the, if you go on apply the force and increase the applied force, obviously at a certain point the body will start move. What is that extent at which the limiting is there? So, that extent of friction at which the maximum friction is there, that is called limiting friction. It is existing from 0 to F less than or equal to FL. It is denoted by FL, that is limiting friction. So, limiting friction is inversely proportional to the normal reaction. It can be further given FL is equal to mu s n. FL is equal to mu s n, where mu s is the coefficient of static friction, and n is the normal reaction. So, from this we can get that certain limit is there. If we apply the force beyond that limit, then the body will start moving. That limit up to which the friction is existing, that friction is called limiting friction. Here also the body is tending to move, but not at all moving. So, here also the body is at rest. Now, let us see the third case. What is kinetic friction? Again, the name suggests kinetic means in motion. When a body is in relative motion, When a body is in relative motion, a friction comes into play, that is called kinetic friction, which is always constant. So, kinetic friction is always constant. Kinetic friction is always constant. Here kinetic friction is denoted by Fk, and it is directly again proportional to normal reaction, and it can be given Fk is equal to mu k n. Fk is equal to mu k n, where mu k is the coefficient of kinetic friction. So, static friction, limiting friction and kinetic friction. Static friction is the friction when a body is tendency to move, but it is not at all moving. So, the force applied is countered by the opposite direction force, that is static friction. Limiting friction is the limit up to which a body can withhold the applied force, but still in this case also the body is at rest. In the kinetic friction, the case is different. When a body is in relative motion, that is the body is in motion, the force which comes into play, that is called the kinetic friction, and which is constant always throughout the motion, and it is independent of velocity. This is independent of velocity and acceleration, which is independent of velocity and acceleration. This is about the types of friction. Now let us take an example to understand the concept of static friction, limiting friction and kinetic friction. Let us take two boys are there and applying force, and this is one force and this is another force, both are applying the force. Okay, let us take it in diagram. So this is one force and this is another force. Say boy A and boy B. His limiting friction, that is a limit of applying force, is say 0 to 12 Newton. He is having say 20 Newton force. He has got the capacity to apply 12 at the maximum of 12 Newton only. He has the capacity of applying 20 Newton. Say initially A is applying 5 Newton, B is applying 5 Newton force. So there won't be any changes. What force is applied by A is counterly applied by B also. So the net is rest, that is there won't be any change, the action will be like this still. Again A is applying 10 Newton, B is applying obviously 10 Newton, again it is in rest. Though he is applying 10 Newton, counterly B is also applying 10 Newton. So what all the forces applied by the A is counterly applied by the B also. So we can say static friction is adjustable force. Static friction, we are having adjustable force. We are having adjustable force. That means what all the force applied by A is countered by B. In the third case, A is applying 12 Newton and B is applying 12 Newton. Here also he has the capacity of 12 Newton. He applied his maximum force. He has applied 12 Newton. Now also the body is at rest, there is no reaction. So this leads to the limiting friction. This leads to the limiting friction. These two are static friction. These two are static friction. Again, A is applying 20 Newton and B, we know that B can apply at the maximum of 12 Newton only. So 12 Newton. So what happens? The force applied by A is greater than the force applied by B. So obviously this will be having direction force in this direction. So the body starts moving. So the case will be like this. So in motion. So having this simple example, we can understand static friction, limiting friction and kinetic friction. In the initial two cases, there is no change because that is the static friction. It does not mean that B is not applying force. B is applying force, but according to the force applied by the boy A. In the third case, 12 Newton is applied and B also applies 12 Newton. That means he has applied its maximum. Still the body is at rest. That means there is no change. In the fourth case, A is applying 20 Newton and B is applying 12 Newton. That means the force applied by A is greater than force applied by B. So obviously he will move in the direction the greater the force that will move in this direction. So, the body is in motion, that motion is friction is called kinetic friction. If you understand this example, you could understand the types of friction, that is static friction, limiting friction and kinetic friction nicely. Now, let us see the graphical representation of friction. Let us have the graph like this. Y axis we are taking friction, and in x axis we are taking applied force. In initial cases, in static friction, we see that what all the applied force is there, the frictional force is also same. So, we can have, when both are same, we can have a straight line. Up to what extent it will be straight line? What all the applied force is there, that is countered by the frictional force up to certain limit, that is the limiting friction, that is the limiting friction. That means friction has attained its maximum limit, that is frictional limiting friction. After that still applied force exceeds, then what happens? Suddenly the limiting force will come down and start in motion like this straight, because kinetic friction is constant. So, this is the kinetic friction. The body is static, that is a static friction. The body is at rest, the body is in motion here. This is the point, that is limiting friction point. From the graph, what we can get is, up to certain extent, up to the body is static, the ratio of frictional force and the applied force is going straight. After reaching the limit, that is maximum limit of friction, that is limiting friction, it reaches here, then also it is straight, and here also the body is at rest. When we apply applied force much greater, then what happens? Suddenly there is a decrease in the friction and starts moving in the same direction, same value, that is kinetic friction is equal to constant. Kinetic friction is constant. From this graph, we can understand the concept of static friction, limiting friction and kinetic friction solidly. Let us take a simple example here. 4 kg block is there. Obviously, the downward force will be 4g, that is mg, 4g. Counter reaction, that is normal reaction, is upward. When a force of 10 Newton is applied, then find frictional force, and mu k is given 0.2 and g we need to take 10 meter per second square. So, in this case action is equal to reaction, So, we can write N is equal to mg, So, m is equal to 4 kg into g is taken as 10. So, N is equal to, normal reaction is 40. Then we have to find the frictional force, that is we know Fk is equal to mu k n. Fk is equal to mu k n. What is mu k given here? That is 0.2 into n. N is equal to 40. So, we can write 40, that is equal to 8. So, Fk is equal to 8. So, frictional force is 8 acting along this direction. So, that can be written 8 Newton. So, from this figure we can get the idea that it is moving with 10 Newton force and this counter force is 8 Newton. Obviously, this is greater than this. So, the motion will be in this direction. So, in order to find the acceleration, we know that net force is equal to ma, net force is equal to ma. What is the net force? That is 10 minus 8. So, 10 minus 8 is equal to mass 4 kg, A, 4A. So, this will become A is equal to 10 minus 8, 2 by 4, that is 1 by 2. So, A is equal to 0.5 meter per second square. So, we can find the kinetic friction and acceleration much easily. Now, let us see another example. 4 kg block is there and the downward will be 4g, that is mg, that is 4g, and the counter force, that is normal reaction n. And in this case, the force applied is not parallel, the force applied is in this direction, making an angle theta with the surface, Obviously, the nearby direction will become f cos theta and the farther one is f sin theta. And the force given here is F is equal to 10 root 2 Newton. When a force is applied in this direction, we need to find normal reaction, kinetic friction and acceleration. What is given? Mu k is equal to 0.3 and g we have to take 10 meter per second square. Okay. Let us take the angle B, instead of theta let us take 45 degree. Then how to find the normal reaction? Action is equal to reaction. So, what is in action? mg. In normal reaction, n plus f sin theta. n plus f sin theta. So, n we can have n is equal to mg minus f sin theta. mg 4 into 10 minus what is f given? 10 root 2 Newton. So, we can write 10 root 2 into, instead of sin theta we can write sin 45 degree. What is the value of sin 45 degree here? Is 1 by root 2. So, root 2 will get cancelled. 4 tens are 40 minus 10, that is equal to 30. So, normal reaction we have found 30. So, first is over. Second, kinetic friction. So, what is the formula? Kinetic friction, Fk is equal to mu k n. What is the value of mu k given here? 0.3. So, 0.3 into n is already calculated. So, 30. So, this becomes 9. Fk is equal to 9 Newton. So, we can represent this Fk we have calculated, this is 9 Newton. So, this force is lesser than this one. Obviously, the body will have the tendency to move in this direction. So, in this question we have found normal reaction, kinetic friction and acceleration also. So, comparing to the previous question and this question, the force applied is in this direction. In this case, the force applied is in this direction. So, due to this, the net acceleration is reduced. The normal reaction plus sum of this is equal to 4g. So, altogether, having these two examples, you could have got the simple concept of static friction, kinetic friction and the limiting friction. Next is angle of friction. Let us consider a block here and normal reaction will be upward, then kinetic friction is in this direction. So, where will be the resultant contact force? Obviously, this is one direction and this is one direction, that is the normal reaction making an angle theta. So, this will be the resultant contact force, this will be the resultant contact force making an angle theta. So, tan theta is equal to mu s, tan theta is equal to mu s. So, we can write theta is equal to tan inverse mu s, which is called angle of friction, that is called angle of friction. In today's class, we have dealt with the deleted topics in this chapter: friction, definition and exemplars. Cause of friction we have seen, that is due to the irregularity in the surface. Types of friction, in types of friction we have seen static friction, limiting friction and kinetic friction, and we have represented it in graphical way also, that is graphical representation of types of friction, and exemplar problems also we have seen. Due to the time constraint, we are not able to deal with the banking of road, horizontal road, velocity, etc. We will be dealing it with the next class. Hope you all might have understood the concept of static friction, limiting friction and kinetic friction. We will see in the next class. Thank you.